airborne and all. Good to see you again. Now today, we're going to look at an incremental encoder on my encoder tester. Here's the screen for the encoder tester. My encoder tester processes the signals from the encoder, passes through my encoder board into this PC running Windows 98. And I used Visual Basic 6 as the program that I wrote the code to process that data and display it on the screen right here. Now we're going to get closer to the screen and we're going to perform some tests on that incremental encoder. Let's get started. The cooling fans are kind of noisy. I have to apologize for that. They keep the stepper motor cool when you run it for long durations of time, which we do sometimes when we're testing encoders. And they also keep the MOSFET drivers that run that stepper motor cool. So, here's our program. Let me get that mouse out of the way. Right here, we have the counters for the A bar, B bar, and Z bar, Z being the home pulse. Down here we have the actual ones and zeros that represent the A bar, B bar, Z bar that the program here processes to display these numeric values. Up here is the start test, stop test, and clear. We can also record the waveform and then play it back later. Here's the record button, the stop button, and the play button. This bank of buttons and numeric values, we can change the direction that the encoder is rotating with these buttons right here. And we can speed and slow down the stepper motor. Let's go ahead and press start. There's our waveforms. Up here is A, here is B, here's the home pulse Z, there's A bar, B bar, and Z bar down here on the bottom. There's a couple of tests that we can do. Let me stop and clear the screen. Right here we can count the pulses between the home pulses. So what will happen is when a home pulse is encountered, it will start counting. And when when it rotates one revolution and we have reached that home pulse again, the stepper motor stops. Let's perform that test. We'll click on the radio button, yes. It says click OK to start, test, or cancel to exit to the test. So we'll click OK. Now, when we reach the home pulse, the count will start over. And when we reach the next home pulse, one revolution, the stepper motor will stop, and we'll be able to look down here and see what the encoder count is. There we go. We've hit our home pulse. A bar, B bar have reset to 0 and they're counting. from 0 up to the next home pulse. All right, there we've stopped. The stepper motor has stopped. And it says here, encoder pulse count equals 500. So, between home pulses, we have 500 count encoder. Let's click OK. We can also look down here. AA bar, BB bar equals 500. Now let's clear that out. The next test we can perform, missing pulses. This is a common occurrence in encoders. An encoder will either fill up with sawdust or it will get oils on the wheel that deflect the light. So we'll go down here and click this radio button right here, missing pulses test. And it says click OK. Click OK, I can speak. Click OK to start test or cancel to exit test. Let's click OK. Oh, sorry about that. Gotta click the power on button. Okay, we're ready. Let's click yes again. And to turn motor power back on. Now what's going to happen is the same thing. We're going to see a home pulse, and then we're going to reset the counters, and we're looking for missing pulses. If A and A bar are not equal, or B and B bar are not equal, or A and B are not equal, then we have missing pulses. All right, we've just hit the home pulse. The counters have reset. Now we know that the encoder is a 500 pulse encoder. There we are. Encoder pulse count equals 500. Encoder passed the missing pulse test. Okay. So, if we had a difference between the A bar, B bar, or A and B, or A bar and B bar, we would have failed the test. Let's clear the screen. Now, we can stop at home. Click on this radio button down here, stop at home. Well, why would you want to do that? Sometimes you want to see what the home pulse looks like in relation to the A and the B pulse. So let's do that. Clear. There we go. When we reach the home pulse, the program here will stop the stepper motor, and we'll get to look and see how that home pulse is displayed in relation to the A and B, and the A bar and the B bar. Almost there. There it is. Okay. Now I changed the colors on the screen so that you could see how the home pulse, this is the Z pulse right here, and this is Z bar. You can see how it lines up in relation to the A and the B, and the A bar and the B bar. Very nice. Okay, let's clear out the screen there. The next test down here that we can do is reset at home. And what that will do is the counters, when we see the first home pulse, the counters will reset to 0. The reason we want to do that, let's say we want to run 10 revolutions or 15 or 20 revolutions of your encoder. And we want to start at the home pulse. When we get done running that encoder through X number of revolutions, we can take our count and divide it by, in this instance, 500 and see if we get the same number of home pulses. And running it through multiple revolutions will also possibly show up miscounts where we miss a pulse here and there and other abnormalities. Let's make sure we're still running. Yes, we are. It's clear. Reset at home, radio button set to yes. Here we go. Now watch our counters. When we get to the first home pulse, our A and B counters will clear, as well as the A bar and the B bar. There we go. Our counters have reset. Our Z pulse is at 0. When this equals 1, we should have 500 there in the counters. When this equals 2, 2 times 500, we should have 1,000 here. 3, 1,500 right here. Let's let it run out and see if that's true. This gives you a chance to run your encoder through a length of time to see if it fails. There we are. There's one home pulse, and we had 500 in the counters. We're almost at 1,000. This should be getting ready to go to 2, the home pulse. There's 1,000. We just went to 2, and we saw the home pulse come up. We're almost at 1,500, nearly there. When that occurs, we will have 3 home pulses. There's 1,500. We have 3 home pulses. 3 times 500 is 1,500. We'll go to 2,000. Almost there. There's 1,900. 100 more pulses to go. There's 2,000. We have 4 home pulses. Let's go ahead and stop right there. Is all our numbers the same? They're pretty close. Okay. I can also check the pulse width. Now, we'll go ahead and click yes on tuning width. A perfect encoder will have a 50% duty cycle. And I've got this program dialed in to 49.5 to 50.5, a window between those two values right there. I don't know if you can see the number, but on this encoder, our pulse width on the A waveform is 43.8, just changed to 44.2. The pulse width, the duty cycle on the B is 45.8, and the duty cycle on the A is 44.8. So the high side is less than the low side on this encoder. And we're outside the range right here, so that's why it says bad. If we were inside this window of 49.5 to 50.5 that I've got a program set to, this would say good. So the perfect encoder would have a 50% duty cycle, but this one's a little bit low on the high side. That means that the high side is narrower than the low side. Still works though. Let's exit out of here. We can also, with my program, trigger on A or trigger on B. I'm going to click the radio button for trigger on channel A. And what the program will try to do, it will try to take this point right here and make it high all the time. And that way the screen, the waveforms don't scroll off the screen this way or that way. It always tries to stay high right there. You can get a better visual look at your waveforms when they're not moving left or right. They're stayed right there in the middle. There you go. Isn't that fascinating, all the little tests you can do with encoder? Try doing that by hand. I'd lose count after 25 pulses. Looking at it with a scope, rotating it by hand. Done it before, still do it, but it's much easier with my robot, my encoder tester. Well, she's a good robot. She does really nice. Hard worker she is. This selector switch right here selects the 3 different voltages of encoders that I normally work on. There'll be 5-volt encoders, 12-volt encoders, or 24-volt encoders. So this knob right here, I can rotate it to the voltage required to power up that encoder. This encoder that we're testing is a 12-volt encoder. Its actual value, voltage value is 8 to 24, but I set it to the nominal voltage of 12. Here's our encoder right here. This is the stepper motor. This is the board that processes the signals from the encoder and converts them to be processed by the computer. She's a good working robot. I started putting her together back in 2001, and I've been working on her program ever since. Trying to get the little bugs out here and there and make it more efficient. There's still bugs in the program, but they're minor. They don't interfere with the work that's being done. So I haven't really taken care of the program like I should, but it works. It works. 2001. Shoo, that was a long time ago. We were a little bit younger back then, weren't we? A little bit smarter too. I don't know if I could put this thing together today. You know how it is when you get an idea in your mind and you want to get it out into the real world and see if it actually works. Took a lot of effort to make that. A lot of effort in the program. Doggone. 20 years, over 20 years of trying to make it do this and make it do that. And, oh well, I'm rambling now. Reminiscing. All right, folks. Have you a good day. Tomorrow's my grandson's birthday. I'm going to go out and get him a birthday present. That's going to be a good day. The better generation's coming up behind us. Oh, yeah.